Kia ora. Thanks for all coming along. Last session on a Sunday afternoon. I'm Anita, and I'm here to show you today how you can build and hack your own IoT using MQTT. So by build, I mean I'm going to show you how to build a demo system like this one here. And by hack, I mean that we're going to do some security testing live. So fingers crossed. First of all, a little bit about me. A lot of what I do in my day job is design and build prototypes of really exciting new products. And often, these products will magically communicate with other things. I write a lot of software, but I'm not a security expert, just as a wee caveat there. I'm really excited by the possibilities that IoT gives us. For example, this morning when I woke up, I got out of bed in a strange environment, stumbled across the room, tried to find the light switch, thankfully eventually got there. But with the IoT and a smart home, I could be lying in bed, snap my fingers, and the lights turn on, which is pretty cool, right? But I also watched this TV program called Mr. Robot. So I'm kind of paranoid. But it's only a smart light bulb. Surely, Anita, I don't need to be that paranoid. Turns out, I found this on the internet, you can infect smart light bulbs with a worm that just keeps spreading and spreading and cause havoc. And for bonus points, you can do it from a drone. Or let's think about something like Mirai, where you can have some malware that infects various IoT devices, and you can take down part of the internet. True story. So yeah, I think we should be at least a little bit paranoid. So where we're going this afternoon, down the left-hand side of those slides up there, you'll see where we're at. And for those of you who like to have references to things, I'm going to give you a slide at the end of the presentation that will give you a link to the slides and some of the code that I've used in here, as well as various other tools and things to read. So what even is MQTT? Let's start with an analogy. Have any of you used HTTP? Lots? Okay, how many of you have used HTTP to interact with a REST API written in C on a microcontroller that's actually only an 8-bit microcontroller with limited RAM? I'm so sorry. It's really hard. So MQTT sits at a similar level to HTTP, but it's much more lightweight, and it's specifically designed for IoT-like applications. For those of you who like your OSI model, I've thrown that up there for you. So first, a few words that are going to be helpful for us to understand. MQTT is a publish-subscribe-based messaging protocol, and I'm going to explain that a bit more in the next slide. There are two main roles in MQTT. There's a broker. Everyone talks to the broker, and the broker makes sure that everyone gets the right messages. The other role is a client. A client might produce data that's publishing, or it might consume data that's subscribing. And the way that we organize or route all of these messages is using topics. Ideally, your topics are going to be reasonably descriptive. So I've given you some examples here. That first one, if I have a sensor on my desk that's sending out temperature data, might look something like that. We can also do some fun things called wildcards. So the hash character will let you get anything that follows on from there. So in this case, I could use sensor/hash to subscribe to all sensor topics everywhere. And finally, because there's always magic, the $sys is used for system messages. That's going to be interesting when we're hacking. But it's much easier to understand this when you see an example. So let's say that I have a smart home system. I've got a thermometer in my lounge, and from my app on my phone, I can see what the temperature is. First of all, what the app would do is it would subscribe to the temperature topic, and it does this by asking the broker. Then, at some point in the future, whenever my thermometer has some new data, it would publish that to the broker, and the broker would then forward that on to the client. That's basically how it works. It's pretty boring, but you can easily add more topics, more clients that are publishing, or more clients that are subscribing. You could also have a client that publishes and subscribes. So that's MQTT 101. I think we're ready to build something now. Let's start with the centerpiece, the broker. In this case, I'm using a Raspberry Pi. All my networking is done with Wi-Fi. I've used Docker to deploy the broker onto the Raspberry Pi. It makes it pretty easy to deploy onto a variety of platforms. And the broker that I'm using is Mosquitto. Mosquitto comes from the Eclipse Foundation, and it's used a lot. That means there's a lot of code examples online. Makes life a bit easier. And we're all smart here, right? So we're going to have password-based login because we don't want anyone hacking our system. So how do we get this working? The Docker file describes everything that Docker needs to build the broker. We have some packages. We copy some configuration files. We're smart, so we hash our passwords so that they're not in there in clear text. And our base image is Alpine 3.9. And I've checked that the version of Mosquitto that we're using doesn't have any known vulnerabilities. And in the future, I'll keep updating that, as I hope we all do. But, you know, this is a Python conference. So as a brief aside, if you want to do all of this in Python, HBMQTT is a great starting point. You'll need a configuration file, which just tells your broker what to do. That's the top half of the slide there. Then we use this command down here to start the broker. In the next terminal, we create a client which is subscribing to a topic. And that topic down here is test message. And then in another terminal again, we create a client that's publishing, and there goes our hi world. Back onto the stuff that we're using here. For the scripts that I'll be running on my laptop, I'm using Peiho MQTT. Again, this one's provided by the Eclipse Foundation, lots of examples. And we've all heard about ESP32s. So I've got some ESP32s here and in some black boxes. These ones have got LEDs. I've got a temperature and humidity sensor here. And I've got an innocent looking red button. Yes. So that's just so you don't accidentally turn on your lights. How do we actually do that MicroPython-y stuff? One thing I love about MQTT is it makes it really easy to write event-driven software. So the first thing you'll need to do on a client in MQTT is connect to the broker. Once you've done that, whenever you have new data available, you can publish it. It's pretty easy. You just say which topic you're publishing to, and then encoding your data appropriately. The other thing we can do is subscribe. So my modules that have lights on them have subscribed to that control message that you see down there. I've also set a callback so that whenever we get a message, we check the topic. If that matches and the message says on, we turn the lights on. and you can add more to your heart's content. So we've built a working system. Time for hacking. First of all, some ground rules. Please don't break any laws. Please be nice. Only hack systems that you're allowed to. And for a little bit of context, and so we don't test everything possible, we're going to think of two threats. First of all, someone who has some sort of personal grievance against you. They want to take it out on you. They know where you live. They know who you are. They can probably get within Wi-Fi range of your house. And our second threat is just some random hacker or wannabe or script on the internet somewhere. This person doesn't really know who you are, but they're just looking for some credentials that they can steal or some device that they can get to be on their botnet. And that gives us some boundaries. We can assume that these guys are going to have network access, but not physical access to the devices. First step is recon, and I'm just going to let you read that. So we want to see what's out there. Our first tool is Nmap, Network Mapper. This is great for seeing what kinds of devices are actually out there and what services are they offering. In this example here, we're going to scan a range of devices. We're going to scan specifically on port 1883, which is the default port for MQTT. And that will then tell us which devices have this port open. Once we've figured out which devices or ports are actually interesting, we can do some packet sniffing. When you're running Scapy, you'll probably have to run it as sudo, because it does fun stuff. And in this example here, we're just going to listen into that particular port and grab 100 packets off there. Then we're going to dump them into a PCAP file, so we can use something like Wireshark to analyze them. Scapy does a lot more than this, so if you want to manipulate packets at lower levels, it's a tool that's well worth checking out. So here's some Wireshark that I prepared earlier. It's got a built-in decoder for MQTT packets, so it makes it a bit easier. Here we're looking at an MQTT connect command. So a client is trying to connect to the broker. There's some stuff, blah, 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 blah. Username, root. Password, 1, 2, 3, 4, 5, 6. In clear text for anyone to see. That's awkward. So FYI, default MQTT password login sends your password in clear text. If we want to step back and look further afield, Shodan is kind of like the Google of IoT devices. So you can access worldwide port scans. And yeah, some devices are really not secure. Also a good way to test what kind of things your devices are exposing to the internet. So, time for some fun. So the first tool that I'm going to run is MQTT Pwn. It starts by doing a brute force attack. Then it's going to use those credentials to log into the broker. Then it just listens in to messages that are being passed on the MQTT system. And because we logged in using some valid credentials, we're a totally legitimate client, so we can hear everything. Because I'm a little bit lazy and I don't want to have to type too much, I've created a script that does everything for me. But looking back over it, here we see the brute force credentials. Here we see one of those sys messages that tells us the Mosquitto version, so we can then check if there are any known vulnerabilities against this version of Mosquitto. MQTT Pwn also summarizes a lot of this information for us. And then it gives us some tools to look for available data. So here we see all the topics that messages were passed around on our demo system. And then here I've just filtered for sensor messages. So 24 degrees and 42% humidity, if you trust the uncalibrated sensor that's on there. And finally, we've also got some control messages down here. So that was when I flicked the switch and told the LEDs to do something. MQTT Pwn also gives us some nice tools to export the messages to a CSV file. And we can then use that CSV file to do the simplest thing of all, which is just a replay attack. So we heard some stuff, let's replay it. So did you see the lights do stuff? I'll just hit that again. So that's just some packets that I've captured earlier, and I'm just replaying them. It's all pretty simple, right? Now, if you don't like bright, flashy lights, you might not want to look at them too much. What I'm going to do now is I'm going to replay them really quickly. So stress testing. So that's kind of fun, right? If that was my house, I'd be a bit annoyed right now. And I'm going to stop my script, like, no hands, right? Oops. Yeah, I haven't figured out why yet, but I might just turn it off and on again. Cool, we're working again. So all I was doing there was replaying those messages back really, really quickly, and the system kind of freaked out a bit. The other thing that we can do is fuzzing. So for this fuzzing, I'm going to take some of these messages with perfectly legitimate payloads, and sometimes I'm going to pass them through a fuzzer, which just kind of manipulates them a little bit. The fuzzer I'm using is Redempsa. It's particularly good at manipulating payloads in a way that tends to break software. So you could use it in all sorts of test situations, whether that's protocols or inputs to a function. It's pretty good. So all those packets that you see there that are in red, they're some of the stuff that's being fuzzed. I'll just stop that so you can see what's going on. So with numbers, we can try fun stuff like having multiple negatives in there because it happens to be a string. We can try big numbers. We can try invalid stuff. We can do really random stuff. I'll just turn my lights off again. Oh, oops. I think I broke it again. That would be kind of annoying if that was my house. Okay, and we're working again.
You call that Redempsa?
Redempsa, yeah, I'll give you a link on the last slide. So yeah, we kind of broke stuff. That's the very brief recap of what we did. But I hope you guys are all thinking that there must be a better way to do this. To start with, transport layer security. As someone who comes from embedded land, this kind of feels like a really big gun, but it will wrap your whole MQTT packet in some nice encryption so that someone who's sniffing may not necessarily even know that it's MQTT that you're doing under there. It works at the transport layer for you OSI model people. It also means that you can be sure who you're talking to. So it does this via certificates. So whenever you see that S in HTTPS for your bank's website, that's the same thing that we can use with MQTT. And it's great because it means that some random hacker can't listen in to all your messages. But as with any security, you need to make sure that you set it up right. So use the highest version that you can, and definitely make sure that it's greater than any versions that are known to be broken. You also need to use secure ciphers and protect your keys. They're called secret keys for a reason. So certificates, they're used to verify identities. Make sure that you get them from a trusted CA, that is a certificate authority who signs your certificate to show that it's valid. If someone spoofs your certificate, they've essentially stolen your identity and can impersonate your broker. So you can either sign your own certificates, I'll give you a link at the end, or you can use something like Let's Encrypt to play around with, or there are a number of commercial options. So TLS is really great, but it's not free. It'll cost you in terms of your CPU, RAM, memory, communications bandwidth, which also means power if you're on a low power system. So you might want to look at some alternatives. TLS PSK, that is pre-shared key, is an option which might work on some constrained devices. Or there's payload encryption, which I'll get to in a minute. This is probably a bit small to read, but TLS-SLED is a tool that comes with a lot of security-oriented operating systems, so Kali or Parrot. Mr. Robot uses Kali. That's a great way of just checking your TLS implementation and making sure that there's no obvious mistakes in there. Another thing that we can do is at the application layer, so the MQTT layer itself. Rather than sending passwords over clear text, you can use a certificate to verify the client's identity, so that same kind of certificate that we were using for the TLS. You can also use a decent authentication plugin, and that will be broker specific. And instead of letting everybody see everything, you can limit who has access to which resource using authorization. So in the Mosquitto broker, the mechanism for this is an access control list. So these authentication and authorization mechanisms are implemented on the broker, but you'll also need to have some way of getting the right credentials to all your clients in a safe way. What does that look like in Mosquitto? Something like that. You can read that later. Payload encryption is implemented only on the clients that you want. This is great if you don't trust the broker or if you don't trust some of your clients, but please make sure that you do both encryption and signing. So encryption is where you encrypt it so that no one else can read it. Signing lets you verify that no one's tampered with it. So cryptography is actually really hard, so get someone who's qualified to do that. But the cryptography library in Python has this hazardous materials layer. It's good fun. And in this example, I've just used AES-CCM as the crypto algorithm because it does both encryption and a message authentication code, which is a signature. But in this case, you'll need to make sure that the client at the other end has access to both the key and the nonce. And best practice, if you're going to use this kind of payload encryption, is to have a different key for each different topic, just so that if one key is compromised, you won't have every topic compromised. So couple of take-home points. I know this is just IoT, but please don't send your passwords in clear text. And also, please use good encryption. I've kind of raced through things now due to time limits, but that link up the top, that will give you these slides. It will give you some code examples that you're free to use or not. I've got a list of tools there. MQTT Fuzz for Pi 3. I forked that library because it was Python 2. Now it's Python 3. And if you're fuzzing a protocol where you need to log in first, I've added a feature so that you can not fuzz your login packets. Otherwise, you won't even be able to get past that step. A bunch of other tools, some stuff to read. Thank you. So I think we might have a few minutes left for questions. Yes?
Can't you just cheat for all devices on a separate Wi-Fi network? One joint thing.
So can I just cheat and put all the devices on a separate Wi-Fi network? Yes, you can do that. I'm starting with the base assumption that my Wi-Fi network is hackable. You could also secure it at different layers, so that's totally an option, and don't expose to the outside world what you don't need to.
You mentioned to encrypt the communication with Let's Encrypt. It means that in that case you would need your device to be able to access the internet and verify the Let's Encrypt certificate, right?
Okay, so the question was about if we're using Let's Encrypt to sign our certificate, we'll need access to the internet. So when we have a certificate, we have a thing called a CA file that we can use to verify that that certificate is legit. If you get Let's Encrypt to do it, you might need internet access. I haven't tried it, so I'm not sure if you can get a CA file that you download locally. But if you're online, that would be a good option. I've actually signed my own certificates because this Wi-Fi network is not connected to anything else. So I can check that my certificates are valid. Was there someone else?
So that's for if we're building our own IoT things. I'm guessing there's a bunch of products on the market which may or may not be following any of these recommendations. But so what's the solution for the average consumer who wants a smarter light bulb, navigate this whole minefield?
Okay, so there are some products out there which probably don't follow these recommendations. What does the average consumer use? Or what do they do? Wear a tinfoil hat, live in the woods. Yeah, that's really hard. If you're buying something from a manufacturer that you trust, then hopefully they're going to be better. That's not always the case. So someone like Philips, generally a good brand, but then their light bulbs share your Wi-Fi password in the clear over like Zigbee or something. So be careful as to what you have in your house. Yeah, no great answer there, sorry.
I know it's probably a bit of a moving target, but in terms of devices like ESP32, have you found any that are better than others or any that just garbage and avoid?
So ESP32s, are there any devices that are just garbage and you should avoid? I may not have said it, but the ESP32 doesn't actually check the server certificate. So if someone wants to patch the TLS implementation on there, that would be great. Yeah, use manufacturers that you trust for chips. Do you trust Espressif? It's up to you. Do you trust where it was built? With things like payload encryption that you do later, even your broker can't see what's going on, so maybe using mechanisms like that. Yeah, you might have to ask an expert. Sweet.